Okay, this is a kind of a generic video. What I'll do is talk about the different features of the program. Maybe I can show you a little bit about how you create new programs, download to the processor. I have a video that also shows the download, upload, and it's kind of like your basic must-know functionality. So let's jump right in. Right now, I don't have anything in here, so I'm going to click on File, New, an L16, that's what I've got. I'm going to call this Demo. Say Next. I want to match the firmware right here. So how do I know what it has? Well, I click on RS Links, and if I right-click on the processor and click on Device Properties, it will tell me right here. It's a 33.012 firmware. So it's basically 33. So when I come back to this screen, 33 is correct choice there. 0 modules. I have no add-on cards to this Compact Logics. Now I've got the controller organizer on the left-hand side. If you don't see this, what you can do is go to Window, Reset Window Layout, and it will restore it to this appearance. Some people will make changes to it, which make it look different. And it's always good to go back to the factory standards here. Okay, so on this controller, controller tags will show me what's in it, in the processor. Right now, the only thing it has is the hardware definitions for the inputs and the outputs. So on the outputs, I'll start with that. I have 16 outputs, 0 through 15. I have 16 inputs as well, 0 through 16. They're all currently in the off condition. Okay. They are Boolean data types, which means they're on-off data types. This tag right here, the .data tag, is an integer. So the 16 bits from the 16 inputs come together as a number. So that's interesting. If you right-click on that, let's see if you can change that. Try one more time here. Don't see it. What I was trying to do was change the way the number appears, but can't just yet. That's okay. I'm probably thinking of something else, but if you look at the 2 in front of it, that means it's in binary format. And sure enough, oh, it should be right here. There we go. Sorry, I was looking in the wrong place. If I go to a decimal format, now it's just a number, right? If I go to a hex format, it's a base 16. So normally we just leave it in binary, okay? Didn't mean to get off track there, but like this bit right here is bit 0. Let's see if I can. I have a test wire here. What I'm going to do is plug this in and plug it into. Well, not yet. Let me go online with the processor. What I'm going to do is connect to it, the 1.11. I'm going to download this program to it. Let's see if it works correctly. The program is blank right now, so let's see if it will download. It looks like it did. Okay, I'm in remote program mode. I'm going to go to run mode. Okay, so in run mode, I have a run mode indicator. On the front of the controller, I have a green light that turned on. So I am in run mode. So what I'm going to do is I'm going to connect that input 0 to 24 volts. And you can see it turned into a 1. So when I connect and disconnect it, okay, it turns into a 1. If I change the formatting to decimal, it becomes a number 1. If I move that connection down from input 0 to input 1, that's a 2. In the binary format, it's that bit. Okay. So that's kind of why binary is a little more useful. Here's the next one. That's a 4. If I go to decimal, you can see it's a 4 now. Binary makes more sense because these are on-off inputs anyway. So, okay. So on the outputs, same thing. Have 16 outputs. They're all turned off right now. These would be turned on through the program. Okay, so let's close that screen. On the main task, we have the main program and we have the main routine. So here's the main routine. This is where you do all your work. Okay, you can have additional routines if you want one. So let's add a new routine. We're going to add a new routine. I'm going to call it R2. It's a ladder diagram type. It's in the main program. And there it is, R2. R2 is also blank. Okay. So let's put something in here. I'm just thinking here, what can we do with it? Let's put an output in here. I'm going to call output 1. Output 1, I'd like to connect it to the outside world, so that's going to be an alias tag. It'll be an alias for output 1. Okay. So you see how it turned gray there. If I accept those changes, it's giving me an error. I was waiting for that. This is actually not allowed. You can't have a broken rung in a program. So in the main routine, I'm going to make this one output 0. Okay, so output 0 will be an alias for output 0. And I'm going to accept those changes. Okay. So it turned green, which tells me that it's running, and this indicator tells me it's running, and this indicator tells me it's running. The output is green here, so it is on. I can see it that it's on. Let's go to main program R2. R2 is not green. Well, it should be, but it's not. And it's not because I'm not processing this routine. So what I'll do in the main routine is I'll add a little instruction called the JSR. So I'll click right here. I'll just type JSR, enter. JSR is a jump to subroutine instruction. So when I click on it and click on R2, when I accept those changes, now it's jumping down to R2. So when I click on R2, now it's green, and sure enough, output 1 is actually on. So in this routine, I'm processing this instruction. Then I jump down to the next routine, which is this one, and I process this instruction. So why would I put multiple routines in a program? It's a convenient way to break up large programs so that the function, let's say you have 3 pumps. Each pump could have its own routine, and the logic that runs that pump station could be in that routine. So it keeps things sort of organized, right? It's interesting to note that this processor, the L1, L16, can have up to 32 tasks in it, and each task can have up to 1,000 programs in it. So it's pretty powerful. The problem you run into is you run out of memory before you run out of program. So if I look here at the program, at the PLC information tab, if I go to capacity, Right now it's telling me that, let's see, I've used only a little bit, like 68K out of 300 and technically it's 384 kilobytes of memory for the logic and all that. So I've got a long way to go, right? Also right here, since we're talking about it, this can have a maximum number of 4 Ethernet connections. So it can talk to other PLCs, up to 4 of them. This is at level 1. This is like the basic controller. So it's got the fewest number of connections. Other processors like a level 3 or 4 or 5, 6, 7, 8 has more connections here. So, this is the least expensive of all their products on this family of products. So it has the fewest number of external connections. Okay, so let's close that off. Kind of went off the deep end on that, but it's important to know that you can add more programs if you want more programs. Let's add a new program. It's going to be called P2 program. Well, let's call it program 2. Okay. So P2, right here, open it. I don't have a routine in it, so let's add a new routine. I'm going to call it P2R1. Let's call it P2 main. And I have to configure that. What I'm going to do is right here, click on properties, and I'm going to configure the main routine as P2 main. The main routine is the one that gets executed when program 2 runs. So let's throw in output. What are we up to? Output 2. Output 2. It's an alias for output data 2. Let me talk here about the scope of the variables that I'm creating. Demo is the name of the processor. So that's the highest level. That's the controller level. Main program is the other program. Program 2 is this program. If I make it a program level tag, then I can only access it inside this program. Now this is like a global variable. This is like hardware level stuff. So I should call it, make it available at the demo level. So if I accept those changes, you notice that it's running. Okay. So back here in the main program under R2, it's running as well. The main routine is running, right? So everything is running right now, and the output is on. So these programs can just add, just keep adding to them. You can have up to 1,000 programs. I've never written a program that big, but I guess technically you could do it. Okay, so anyway, a lot of potential over here. Down here at the bottom, embedded I/O. That's what I've got to work with. I have no expansion modules. It calls this module 1, that even though it's internal to the processor. So this is module 1. So when I look at the controller tags, I'll notice a 1 right there. That tells me that's the embedded I/O. Okay, right there. Let me just look for a minute. I didn't pay attention, but when I was creating these names, these were actually main program level names, which is okay. I went ahead and made output 2 a controller level tag. So I think it's generally better to make everything at the controller level so that it's accessible across all the program lines, but that's a programming preference. If you're concerned about something, accidentally turning on output 1, then create it down here at this lower level, and you'll notice you can't see output 1 in program 2 because it only exists in the main program. So it's a decision you'd make up front as to how you want to create your tags. For right now, you can just make them all as I'm closing these off here. You can make them all at the controller level, and you'll see them all listed out right here. Okay, it's kind of a hassle to have them spread across the programs because then you have to go look for them. And I don't know. I've always thought it was just easier to have them all up here at the controller level. Okay. All right, so I have no expansion modules. If I did, I'd see them listed right here. I have one Ethernet module, which is the embedded Ethernet on this. I can add additional Ethernet modules, like from other processors. I do have an easy automation processor on board on this network right now, so I could add that. Let's go ahead and do that. Why not? So that's one of the things that I can't do while this is running. Like if I click on Discover Modules, it can see it. There it is, right? Oh, let's see if I can register that datasheet file. I don't have a datasheet file for it. I wish I did. I'd have to go to easyautomation.net. I'm not going anywhere fast with that. I'd have to go to easyautomation.net and see if they have an EDS file, electronic datasheet file. If they do, then I could import it. I would like to do that because right now, let me go back. Let me go back a little ways here. Notice it's got that question mark. It's not sure what this is, and I would have to jump out to their website. I guess I could do that. Let me do that real quick. I guess those are, I don't know what I'm looking for on their website. So let's see if they have a search. Let's just type in EDS, electronic data sheet. No, let's try one more time. EDS. No. I'm not entirely surprised. They're not making the attempt to integrate with Rockwell software. It is very common in the industry. People don't necessarily want to make things connectable, if that makes sense. You can do it, but they're trying to make it not so super easy to do it. So what I would have to do here, I would have to go offline. I'm going to do it anyway, just because I started down this road. So I'm going to add a new module. The Easy Automation system uses something called a generic Ethernet module. I'm going to create that. I know that the name of that is, I'm going to call it Easy Rack PLC. My data type is an int. Okay, I know all this ahead of time. There's no way anybody would know this ahead of time unless they had already looked at it. My IP address for that controller is 1.2. My input assembly instance is 101 and 102. I've got one byte for each of those set up in that processor. And I'm just going to click my way through. I click on that. I'm going to download to it. I clicked the wrong button. I'm going to stop it before it messes me up. I'm going to download that. So I know this kind of went off the deep end, and it's kind of unfortunate, I guess, but I started down this road of adding an Ethernet module, so I thought I would finish it out just to show you how you do it. Go back to remote run, and I'm going to wait just a second. Now, I know it's going to work, but if there was something wrong, I would get a little message right here. So let me scroll this up. I'm going to unplug the cable from it. How about that? Okay, I just did that. Oh, look at that. I/O faulted. Connection timed out. And I got the little, it's a tiny little triangle right there. So if you see the little triangle here, it tells you that there's a problem. I can't talk to it. So let me go back and find that loose cable and plug it in, and it's all good again. Okay, so if this was a servo drive or some other kind of a, maybe just a drive, a three-phase variable speed drive, if you see a triangle right here, you've got a communications problem, and you need to go ahead and figure out what that is. If you'll just pull that window up, you'll get some information about it. So I'm going to knock it out again. That's quick, right? It's just like instant. Just drops it out. And it should come back. There it goes. Okay, now enough about that. Also notice right here under the controller tags that when I added that module, I added some data from that controller. So it's importing additional tags for me to use in my program here. Okay, I'm going to close that off. So let's go back up here real quick. I've got some indicator lights. These sort of mirror what's on the processor. It is in run mode. It is okay. I/O's okay. Let me unplug that cord one more time. Oh, look at that. So when I see that, it tells me there's a problem. Something's not right. It's not responding. On the PLC itself, it's blinking. So I'm going to plug that cord back in there, and it's solid green again. So green is good. Green is good. Yellow is caution. Red means something's broken, like really broken. Okay. Here's my mode selection. If I go to program mode, it stops the processor, so I don't want to do that. Forces, I have no forces enabled. If I turn this on, I can force outputs to turn on, so I'm not going to do that. Here's my RS-Who, my triple dots. I always call it the triple dots because it's just easier. Triple dot will show me who is available to talk to. Okay. You have to have the right driver configuration, and that's through RS links. So if you can't see anybody, you've got either a cabling problem, you've got a computer IP address problem, or you've got the driver set up wrong, something like that. Okay, right next to that, we have the instruction menu, I guess we'll call it. Okay, so let's go back and open the P2 main. Let's work down here for a little bit. My favorites tab has the commonly used instructions, contacts and coils. Okay. Here's some timers. If I want to, let's pull a timer. What I'm going to do is double click on this end to get a blank line. I'm going to pull down a timer. I'm going to call this TR1, time relay 1. Make a new timer. It's a base, always a base tag. The scope is the highest level. Let's call it a demo way at the top. Okay. Notice how the zeros lit up there because now I've created this timer. I can go ahead and do something with it. Let's make it a 12-second timer, 12,000 milliseconds. Okay. I'm going to, now here I've got two programs, so I don't want to accept all changes in all programs. But I think since this is program specific, let's see if it finalize all edits in program 2. P2 main. Oh, this is all good. Yeah, this is fine. What I'm trying to avoid is, like, if I had something potentially pending up here in the main program, I wouldn't want to just close it off as well. So it's okay. It's just local to this program that I'm working in. So I'm going to say sure. Okay. So now here goes the timer. You can see it running. After 12 seconds, it will be done. And there we go. So let's say output 2 should turn on when this thing is done. What I'll do is I will double click on that. I will pull down an open contact. I'll call tr2.dn, and I'll accept those changes. Well, it didn't like that. Oh, my mistake. It's tr1. I'm thinking while I'm typing. Happens sometimes. tr1. Okay. And there we go. So in order to restart this timer, I need to break it somehow. So I don't have a convenient way to do that. I can put a close contact down there. I'm going to call it restart. Right click, new restart. It's a base tag. Create that. What I'm going to do is toggle that. And when I toggle it, I'm going to turn it off. See how it cleared out the timer. I'm going to toggle it back on, and I'm running again. Output 2 will turn on here in about 5-6 seconds. Let's let that run. So I'm down here in program 2, P2 main. See, I can work out of this program. If I go back up here, I can add something to this one. Let's double click that, and let's put a contact called nothing. Right click, new nothing, base tag. Let's put a coil called no out. Right click. Notice the scope of the tag. It's a demo, so it's at the very top. Let's create that. Let's accept those changes only to the main program. That's good. Yes. So if I toggle this nothing bit, I can turn on no out. Interesting, right? Let's go to the controller tags and look at that. So no out is on right now. Let's see if I can force it to turn off. I can't force it off. It keeps going back on again. I could probably force nothing to turn off, because nothing was a base tag. It's not connected to anything like a real switch or anything like that. So I can toggle it here in the monitor tags screen. Right? Output 2, let's see. Let me right click on that and go to cross-reference. Output 2 is in P2 main. Okay, so if I double click on that, it'll take me there. I can't force it off because it's an alias tag, but I can force this off, tr1.done. Let's go back to this one, tr1.done. If I force it off, well, it came right back on because the accumulated value is 12,000. If I make that a 0 and force it off, I can make it restart. Don't normally do this kind of thing. I don't like forcing things on, but you could, like if I was to just toggle that. So use the toggle instructions. Don't go down to the tag level like I was doing, and it's the wrong place to do it. You're not sure what you're doing here because you can't see the logic, right? So you can do a lot of things, but you shouldn't do some things. So going back to this, just kind of like scrolling around here. If I go ahead and turn this back on, let timer run. So I don't know. After a while, it all looks the same. It's just routines. You work at the routine level down here. Your program is a collection of routines. You can look at the properties of it if you want to. You can turn it off. I've never turned off programs, but I guess you could. So you just didn't like program 2 anymore. It's just broken, not working good. Out 2 is on though. Ooh, that's not a good idea. Out 2 was on when I turned it off, and it's still on over there. So I'm gonna re-enable that program. So now if I toggle this bit, turn it off. So yeah, be careful. If you freeze a program by inhibiting it, it doesn't scan it anymore. It just kind of freezes it where it was. So that's not a good idea. Oh, here's your scan time information. Tells you how long it takes for it to process each of the programs. So let's look at the main program. I'm curious now. 26 microseconds. It's pretty quick. Let's start that timer and watch it. 26, 29. It's not very. It's not affecting it very much. And that's the maximum time. So it's quick, 33 microseconds, pretty quick. Okay, so what else can we look at here? All these different functions, like math functions, add, divide, subtract. Maybe let's look at one thing here real quick. Let me see if I can, I don't want to move it around. I was trying to make this reappear with the full names, because, it shrank. When I clicked on that math tab, it shrank. Let's go back to the window, the reset Windows layout. It didn't help. So they shrank down. You'll just have to, I guess, get used to what's available where it is. Stretch to application width. That didn't help at all. Let me go back. Okay, well, I'll quit messing with it. I'm looking for one other thing here that I don't see. Okay, don't see it. Okay, so I guess you'll get familiar with where these instructions are located, and normally your favorites tab will populate with the let's see if I can add this to the favorites. Let's see, favorites. I'm hesitant to do too much, but I'm going to try one thing here. Yeah, there we go. So I can add things to the favorites so I don't have to search for them a lot. And you would think that that's not really a good thing to do, but it is. You'll be surprised how much you can do with just timers, contacts, and coils. Maybe some counters, maybe some math instructions. You don't normally use a lot of these sophisticated instructions, but on occasion you will, so you never know what you'll have to deal with. There's motion control instructions over here for servos, motion move instructions for servo systems. So if you're into that, if you fall into that category where you're later on more complex programs, you'll definitely have to work with this. But this course, being the maintainer level course, we're kind of working with your basic instructions. Nothing too difficult to deal with. Timers, counters. Let's add that to the. I wonder if I can add the whole thing to it. No, I can't do that. RTOs. Let's add an RTO. And I'll talk about RTOs. What's an RTO? An RTO is a retentive timer. So let's do a, let me show you how that works. I had a student ask me that one time. RTO run. Just any, generic name is fine. and we're going to do an RTO timer. We're going to call this RTO1. Retentive timers, this is an RTO. What it means is that it doesn't forget when you turn on this contact here. So the regular timer is like a TON. When I toggle the bit, let's turn it back on. Notice how it's running there. If I turn it off before it times out, it just goes back to 0. So let's toggle the RTO on and off. See how it didn't forget. So an RTO is great if you're trying to track elapsed time, like you want to know when a pump has been running for 3 hours, but that 3 hours might be across 3 months. So, every time you turn it on, you want to increment the run time. So RTOs are good for that. Now, the only thing about an RTO is the only bad thing is once you have it there, you have to reset it. So there's an RES. We're going to do an reset RTO1, and I'll put me a contact called reset RTO1. And this might be a key switch somewhere, or it might be from an HMI touchscreen. Let's change the name of that. We'll call it HMI. So maybe you've got a touchscreen running, and you've got a screen on the touchscreen system where you can click on a little button and reset these timers. So it's not like readily available, but it's, maybe a few screens back. You won't see it unless you know where it is, something like that. Okay, so this video is running kind of long here, but it's a lot of stuff to pick up on. You don't have to know everything right away. I think you'll pick it up as you go. This right here you can use to find things. So let me close off these different windows. And I know I've got an output called RTO. So I'm going to type in RTO and say find it. Okay. And there it is, RTO. Find the next one, there it is. There's an RTO. It's great. If you know the name of something, you can probably find it here. Let's say you don't. Let's see. It's a local. It's one of the local IOs. So I'm just going to type the word local in there. Local, and search for local. Well, that didn't work because these tag names are not the same as the hardware level names. That's no good. What I would do in that case is I would go to controller tags. I've got my local IO right here. If I right click on it, I can go to cross reference for inputs. It will tell me I don't have the inputs used. Well, that's good to know. Local output, right click, cross reference. I have output 0 in this program, in this routine. Output 1 used here, main program, routine 2. Output 2 used down here. If I double click on that, it'll take me there, and there I am. So cross-referencing is great. You click on, double click on that. If you want to go to this nothing contact, cross-reference to it, double click on it, and there I am. So that's the way to go. This search tool it's okay. I mean, like if you have stuff spread across a whole bunch of different programs, like these are program level tags. Let's see if I can. Whoops. Let me do that. Output 0. So I'm going to type in output. Output 0, output 1, output 2. So I can find things at the program level instead of like poking around trying to find them here on these tag listings. I can just search for them up here. Okay, so they both are useful in different ways. This is the logical organizer. The logical organizer doesn't include the hardware connections like this one does. It's got hardware down here. This one's got just program information. So, you know, depending on which level you're working at, I like this view right here. It's got the I/O. Just, I don't know, I've always used this one. It'll show me if I've got some kind of hardware problems. It'll show me that. Okay, so let me close. Here's a neat little function. It showed up a couple of releases ago, and you've got all these different screens queued up here. Let's say I really just want to look at this one. Close all but this. I can close off all those tabs that are open in the background. It gets to be a lot. At some points you've got like 50 tabs open, and it's cluttered, right? So just right click, close all but this, and that's a neat tool that they added some time back. Okay, well, I think that's enough. You might want to watch this video a few times just to pick up on finer things and kind of go from there.